Okay, hi everyone. So this is now a video to explain to you how to do draw a vector diagram for this question. So we first look at this question in your notes. It says there is a boat and a fast moving river. Okay, the mass is there. We don't really need to worry about this now. And there's a force of 225 kilonewton here and a resultant force of 50. So we need to make sense of all these forces to understand this diagram better. So what we know is that there's a force following the current, right? And this force on the boat by the river is 225 kilonewton. Then we know there's a resultant force which is right angles to the riverbank. So the riverbank is this way, a right angle will be up and down. And judging from the force of the engine and the direction of the river current, we're gonna expect the resultant force to be somewhere upwards, right? So if I were to draw this, and then there's another force that is caused by the engine, it will look something like this. And if I were to join up triangle, this will be my resultant force. So the force by the engine I do not know, but I know that the result of these two forces is 50 kilonewton. So this is my sketch. My vector diagram is going to look something like this. This is going to be right angle to this. So now I have a sketch. Let's determine the scale that I need. For this purpose, for the video purpose, I'm going to make it a slightly bigger. Otherwise, I feel that 1 cm is to 25 kilonewtons is about there. But we're going to make it bigger. And so if you don't have a long ruler like mine, you can choose that as well. Okay, so based on this, I want to make sure you make use of the full space. I'm going to choose 1 cm is to 12.5 kilonewton. Okay, again, this is just because I can make use of the space. I tried to use something even bigger scale, but it's too big for the paper. So because of the triangle like this, I'm going to start on the right side now. And I'm going to just draw again a long line to use it as a reference to begin with. Because one of the forces is actually on this line. Otherwise, I would not have used it so long. So I'm going to do a reference from here. And now I know that 225 is here, which means I probably need, let's see now, 8, 16, 18. So I need about 18 cm. So going to be from here, using okay, I don't have it long enough still, so I'm going to extend my line a little bit more. There we go. And going to for 18 cm. So my drawing compass can't be that long, so I'm going to just use my ruler directly. And this is where I will mark it out. Okay, so this is 18 cm long. I'm going to draw an arrow. This represents my 225 kilonewton, and this is because of the river current, force on the boat by the river current. So now I know that my resultant force is going to be right angle. So I'm going to take my protractor, and based on what I've sketched just now, the resultant force will be here. I'm going to mark out 90 degrees again. I'm going to extend this line upwards. Okay, and from here I know that using my scale, since my upward force is 50, so that's about 4 cm. I could use my drawing compass, which I think I should. So to be more precise, 4 cm. Push it a bit more, 4 cm. Okay, this is okay. Mark it from here. Do a arc, and that will be where my 50 kilonewton is. So you can see it's a very long triangle. If this is a bit too long, I can always remove it because I don't really need it. And now, so this is my resultant force. I'm going to put a double arrow there, so to differentiate it. So for this resultant force to happen, there must be a force to this side and a force upwards, or slanted to the left, right. So you're going to start from here and here, and I'm going to draw it. Okay, Okay, now I'm gonna mark out my arrow, and this is my force from engine. And to finish off, I want to measure this force. So let's hope I measure this as accurate as I can. And of course, if I can, I would definitely have used a drawing compass, but this is a bit on the long side. Okay, I see 18.4 cm. And 18.4 cm, if you calculate it using my scale here, I'll get 18.4 times 12.5 kilonewton. I get 230 kilonewton. So this is not a resultant force. In fact, the resultant force is 50, the question gave. We're finding the force of the engine. So this is one part. I need to find the direction. So I'm going to mark out my angle here. And I'm going to use my protractor to mark in the middle and measure. This is about 10, 11, 12, 12.5 is in between two markings. So I'm going to take 12.5. 12.5 degrees. Okay, and there we have it. This is how you do a vector diagram for this question.